So, good afternoon, students. In last class, we were discussing about the sampling, and today we will be continuing our lecture. And we have studied the basically meaning of sampling, then concept in sampling. That is, what are sampling units? What is the population? What is sampling frame? Then what is a sample? What is sample fraction? Sampling process or method? Then census, and what is a population parameter and a sample estimate. Then we have also studied about the advantages of sampling. Then moving on to the next thing, we have studied about the types of sampling. Okay? And in that we have studied about the probability sampling. So yesterday I was telling you that in this random number table, actually it was not updated in last class, so I have now updated it. Okay, so I will be taking that up just so that you will be able to appreciate that how to do the selection of a sample using a random number table. So this random number table, use of this random number table, it comes in your probability sample. Okay, and we were somewhere here trying first this random number table. So this random number table, this I'm just revisiting it because yesterday there were this appendix was not available. So another method of simple random sampling, okay, is to use a random number table. For drawing, say for example, we have done this using a lottery method. So now we can also do this using a random number table. And what we have to do is that we have to select 25 students out of the 600 students. Okay. So the procedure for using a random number table is as follows. How to use it. So students may use this random number table available online. This is the link. Okay. From this link, you can download the random number table or just click here to download the same. Okay. So I am just opening it. Okay. So these are the random number table available on the government site. And how to use these random number tables? I will be just increasing this font that will be more appreciable to you. Okay. So yes. So actually these random number table has been reproduced from the million random digits. Okay. There is a corporation is there which used to develop these million random digits, and from that this particular site on the government has used this. Okay. So basically, how to obtain this random number? Okay, to obtain a random sample, two steps are necessary. First, it is necessary to identify each package in the lot of the package and with a specific number, whether on the shelf. They are just telling about the warehouse or something else. But I will be just telling you that how to do this. Okay. So the random number tables are given in this, and they starts from this table one. Okay, these are the random number tables. Then these are the table two. Then these are table three. So how to make use of that? That is important. So the random number table in appendix B are composed of digits from 0 to 9 with approximately equal frequencies of occurrence. Because they are having equal frequencies of occurrence, these digits in these random number tables. So that is why they they can be having each and every number will be having equal chances of being at select. Okay, and it consists of 8 pages. On each page, digits are printed in blocks of 5 columns and 5 blocks of 5 rows. So if you see this, so there are 5 these rows are there, okay, and each block is having 5 rows. So that you will be able to understand that in which row I am working. Okay. So this is there. Okay. And this it is intended only to make it easier to locate the specific column or a row. Okay. So basically, in the starting page, the random digits page numbered B2 to B8. So you can use the day of the week to determine the starting page, or use the first page for the first lot of your testing location, then second page for the second lot, and so on, moving the following page for each new lot. Okay. Similarly, starting column and row. How you can do that? You may choose a starting page in random number table with the eyes closed and simply drop a pencil anywhere on the page to indicate a starting place in the table. Okay. So, for example, assuming that testing take place on third day of the week, start with the table 3, appendix B, and assume you dropped your pencil on the page and it has indicated a starting place at the column 22, row 45. So that is number 1. Okay. So basically, this is how we use these random tables. So in our this practical, now let us see how we will be using. So number each element of the sample frame from 1 to 600, because we are having 600 students. Okay. Now decide a random starting point in the table as per the directions given thereof. Suppose as per the direction we pointed third row, fourth column in table 2. Say for example, it is the day 2, and we have selected first the randomly the table 2, and then we have dropped our pencil, and that pencil has pointed on the third row and the fourth column. Okay. So look at the first 3 digit at that point, because there are 3 digits in 600. Okay. Then, if the number is less than say 600, include it in the sample. If not, then look for a number where the number of 3 digits are less than 600. So from that point, you can move in any direction, because every digit has been placed in the table at random. So select only 3 digit number that are less than 600 until you have 25 sections. So what I did, I started in the table 2, third row and fourth column. So this is the table 2, third row. This is the third row and fourth column. So this is the fourth column, and then I moved on this side. So basically, if you see, so I have written these numbers here. What you have to look for is, what you have to do is that you have to look for only first 3 digits, because 600 is a 3 digit number. Okay. Then this 179. Okay. Then this will be 114. Then this will be 226. This will be 347, and this will be 257. And all these numbers are less than 600. So they get selected. And simply like this, you have to select a random number until you get the 25 set. Okay. So this is how you can use a random number table for selecting the individuals. Okay. So that was left yesterday. So I have included. So now we will be moving on to, we have been completed with this your particularly the probability sampling, and now we will be moving on to your known probability sampling method. Okay. So starting this known probability sampling. So a known probability sample is the one which a case in a sample is chosen in such a manner that it gives you information for the sample itself and makes it possible to generalize the finding for the population with certain degree of precision. Means there is a certain degree of precision is there. Okay. Now, such a sample is also called a, what it is also known as? It is also known as purposive sample. Okay. And this kind of sampling is primarily used to collect the information on market survey to know the, say for example, this attitude, opinion, behavior, reactions of individuals. So there are many type of known probability sampling, and these are also basically these are designed when this probability sampling is not finding its place in our system. Okay, and here this randomly selected samples are more precise as compared to known probabilities. Then we will be seeing that in which conditions we are using this. Okay, so there are many types of known probability samples, including like snowball sampling. Okay, then we have convenience sampling. Okay, then we have purposive or judgment sampling. Then we have quota sampling. Okay, so we will be studying them one by one. So what is a convenience sample? So the convenience sample is also called so this name, how it is derived, because it is relatively easy to obtain and contact. Okay, so this sampling is mainly framed just for the ease. Okay, so in this method, the investigator are usually asked to select the people for the interview in accordance to the instruction from the researcher. The benefit of a convenience sample is that interviewer can usually get interviews done quickly and cheaply. And convenience sampling is appropriate for exploratory type of research. Okay, that is just you want to explore that what is happening. So just for that you need not to go for this probability type of sampling. And as per your convenience, okay, go there whenever you find any these two persons. Okay, ask them like that. Now judgment sample. What is a judgment sample? A judgment sample is similar to convenience sample. But in a judgment sample, the researcher does not depute some. He selects the sample and he to whom he believes that this represents the population. Okay. Say for example, I want to find out that what is the mean performance of a dairy farm. I go there, then I select 10 buffaloes, which I think that they are the true representative of the this population. So based on my judgment and experience, I am selecting the individuals. Okay, so it varies from one person to person, another person. So the selection of sample is based on the knowledge of the population and the characteristic which the sample is to represent. So it is less costly and very useful for forecasting. If you just want to forecast, for that type of purposes, this judgment sampling is being done. Now, what is a quota sampling? Quota sampling is like stratified sampling. Okay? In quota sampling, what they do, the population is first categorized into several strata, which consist of an expected size, and the samples are considered to be important for the population they represent. The advantage of quota sample are that it involves a short time duration, is less costly, and gives moderate representation of a heterogeneous population. Of course, stratified stratas are made, but out of that, we select the sample which we think that represent the population or that is true. Okay. So, as per our judgment type or we do this, then snowball sampling. This is one of the important type of known probability sampling. And in snowball sampling, the investigator encourages the respondent to give the names of other acquaintances. And it continues growing in size and the chains until the research purpose is achieved. Say, for example, a phone comes to me and that person says, Sir, are you interested in purchasing bungalow? Okay. I said, no, I am not interested in purchasing a bungalow. So he might tell me that, sir, can you give me some references of your friends who might be interested in purchasing a bungalow? So then I say, oh yes, yes, that person was asking that day. So he might be interested. Can give, I will give his number. So accordingly, like this snowball sampling, as per the requirement of the study, we approach some people. If they give us the responses, okay, then we ask them, then to whom we should meet. And this type of sampling is very much done in case of marketing, because you go to one person, you use their intellect and you ask them, sir, which other people we should meet to promote our this product. So this snowball sampling is very much in use in market. So now comes your sample design process. What is the sample design process? First of all, that is in sampling method, how we should proceed. These are the steps. So first of all, we have to define the population, of course. So we use the word population frequently, okay? And in our day-to-day conversation, for example, the population of India or the population of Punjab or the population of Kerala. However, the meaning of the word population in research is different for what we use in day-to-day conversation. Okay? A research population may be defined as research population. What is a research population? On which a study is made. So it can be defined as a clearly defined group of entities that have some characteristic in one. Okay? So it is a research, right? Now, this means the kind of people on whom we wish to base our research project. Okay, means on which type of people we are going to base our research. Sometimes in research we use word universe instead of. So in a research project, our intention is to learn or infer something about the population. Whether we use a sample or a population has to be clearly first defined. For example, if we want to conduct a study on road safety, then the task of defining the population for the survey would be better. We should interview only the people who drive two-wheelers sampling. Okay. Interview only the people who drive four-wheelers. Then interview the pedestrians and interview only who are hand rickshaw pullers or the ride bicycle. So we have defined that to whom we should interview. Okay. So this is how we defined our population. Therefore, judging a population is the starting of the sampling. So when you are conducting a study, first of all, you have to judge that which will be your target population of this. Okay. Sample versus census. So after judging the population, the next step in sampling process is to decide whether to take a sample or a population in your research. Okay. So in a census, usually every member of the population is interviewed, while in sample method only selected member. Okay. So in case of census, we usually have every member. Okay. And in case of sample, right, we use only selected members, right? So from the census, we obtain data that are called population parameters. Okay. And from the sample, we obtain statistic, right? Not population. So parameter is a measurement of a characteristic of the population, while the sample statistic is used as an estimate of sample parameter. Sample. So usually in individual research, we use census when the population is small and sample when the population is a simple criteria, right? So basically, now once you have decided that whether you will be going with a census or a sample, okay, then you have to construct a sampling frame, right? So what is a sampling frame? A sampling frame is a listing of all the elements from which you will draw the sample, right? That is all the elements, all the people from which you are going to collect the sample that you have to define and make a list. And that list is known as your sampling frame. So in the ideal situation, sampling frame will include all elementary units in the target population. Say, for example, a list of employees in an organization can create a sampling frame that exactly matches the population of interest. So you should try to ensure that the sampling frame has the following characteristics. What are the characteristics of a sampling frame? It is actually created from the target population. Okay. Then it is a complete list as possible of the elements in the population. That's it. Right. Now, what is the difference between this probability? Then we have to look upon. First, we have selected, so what were the steps? So, first step was we have defined the population. Then we have chosen whether to go for a sample or a census. Then we have defined our sampling frame. And then we have to choose from that whether we have to use probability or non-probability. Okay. So the fourth step in sampling process is whether to use the probability sampling or non-probability sampling. So in a probability sample, the sample elements are chosen by random selection. You know, okay, we have already discussed. While in non-probability sampling, each element is chosen according to whether the researcher decides that it should be included or not. So in case of non-probability sampling, researcher decides. Okay. So you have to judge that which type of sampling you will prefer, and accordingly you will be getting the precision. Then comes your last sampling method. That is what we have discussed. Various probability sampling methods or non-probability sampling that you have to find. So last but not least in the sampling process, in the selection of the sampling method, in the probability method, sampling method, the following four principal kind of probability sampling are used, like simple random sampling, okay. Then maybe you can use a systematic sample, or you may use a stratified, right? Or you may use a cluster sample, right? And in case of non-probability sampling, you can go for convenience, okay, or a judgment sample, or a quota sample, right? Or a snowball sample. So these are the 5 steps to go about a sampling procedure. That how you will do the sampling in a time. Now, once you have done the sampling, there are certain characteristics which you need to understand about the sample, right? And those will be affecting the statistic, further statistic, and the inferences you will make out of that sample, and will infer that these are the values for the population. Okay. Now, let us see that what is a sampling distribution. We have already been through with the probability distribution. So now here we will be studying the sampling distribution. Because in a population you are drawing the sample, and when you are drawing the sample using the probability sampling method, means probability sampling. So every individual have the equal chance of getting selected. So this time may be possible the individual which got selected may not be selected next time in the sample. So let us see that what happens in that scenario. So in many situations, if we extract some information from all the elements or items of a large population in general, it may be very time consuming and expensive, right? So if we go about whole of the population, all we know that it is very time consuming and expensive. Also, if the elements or items of the population are destroyed, means they get destroyed during the your this investigation. Maybe, say for example, in case of livestock products technology, when you will be in third year, so you will be judging this meat characteristics. For that, you have to sacrifice them. So you cannot go for sacrificing all the animals in the population, right? So that is why you have to go for the sample. So then the information gathered from the all the elements is not making sense, because all the elements will be destroyed in that case. Okay. So therefore, in most of the cases in daily life, business and industry, the information is gathered by means of sampling, and that is what we are studying. So the result of a properly taken sample enable the investigator to arrive at generalization that are valid for the entire population, right? So the process of generalizing sample result to the population is called as statistical inference, and hence the name is inferential statistics, right? So what is this? The process of generalizing sample result to the population is called statistical inference, right? So for drawing inference about the population parameters, we draw all possible samples of same size, right? And determine a function of sample values. which is called a statistic. Okay, note it here that if you do for the population, it is a parameter, whereas when you take out a sample and conduct the statistical analysis, find out mean, variance of these, so these are known as statistics. So the value of statistics are generally varied from this statistic which you will observe, generally varied from one sample to the another. That is when you will be drawing samples. So one sample might not be having the similar statistics as the other, whereas in case of population, they are constant. Right? Therefore, sample statistic is a random variable. This is very important. Okay. So, any sample statistic is not constant. It will vary and it depends on the chance that which sample has been selected from the, and therefore it follows a, so the distribution of the statistic is called sampling distribution of the statistics. So because every time when you will be taking a sample, taking out the mean, then another sample, then mean, another sample from the population, then mean. So these mean will be random variable. And because they depend on the chance, so these random variable will be following a distribution. And this distribution is known as sampling distribution. Okay? So the concept of sampling distribution. Now we will try to understand that how this sampling distribution. So we analyze the sample data for drawing the inference about the population. Now we calculate the sample statistic as sample mean. If we are taking the mean of a sample, it is known as sample mean or sample proportion or sample variance. We calculate from the sample, right? Okay. So generally, if we want to draw the inference about the population mean, we use sample mean about the population variance, and we use sample variance. If we want to draw the inference about the population variance, then we use sample. So, for example, suppose we want to study the average life of a electric bulb produced by a company, and we decide to estimate the average life of electric bulbs on the basis of a sample, right? So we take a sample, say for example, 10 bulbs from that factory. So it might be producing thousands. Okay. So we have taken a 10 bulbs and measure the life of each bulb selected in the sample. The observed value of the life of the bulbs are given in column 2 of the table. Okay. So what we do, we have selected a sample and 10 bulbs, then measured their mean life in hours. So these are the 10 in sample 1. These are the another 10 bulbs in sample 2. So the mean life came out to be 10,400, and in this case in sample 2 it gets 8,600. Right. So the mean value was 1040 for sample 1, whereas it is only 860 for the sample 2. Right. Now from the above table, the average mean life of these selected bulbs is 1040 hours in sample 1. Now we are using the sample to make inference about the population average life. We can say that the sample mean is 1040 hours and gives an estimate of the average life of electric bulb for the whole of the population. That is all the bulbs produced in the that factory. Now, but if we take another sample, sample size 10 from the population, calculate the sample mean as shown in the above table. The average life of bulb selected in sample 2 is 860 hours. This is different from the mean in the sample 1. So, thus, if we are using the sample mean to estimate the population mean, then we get a different estimate of average life of buffaloes, oh sorry, not of bulbs for whole population. Similarly, we can take many samples of same size 10 from each sample. So, we get a sample mean which may or may not be distinct. That is, be random. So from all of the sample means we try to estimate the average life of the bulb of the whole population, right? So for better understanding of this thing, uh, understanding of the process, generalizing these sample results to the whole population, we consider the example in which size of population is because here the number of bulbs are very high. So now let us consider another population. So consider a population comprising of four typists, right? Who type the sample page of a manuscript and the number of errors made by each typist are given here. Okay, say for example, there are four typists are there and they make four error, two error, three error, and one error. Now, this constitute the whole population, these four typists. So the population mean average number of errors can be obtained as, so you have to add them up and then divided it by 4. So you will be getting the population parameter, that is population mean 2.5 errors per inch, right? Now let us assume that we do not know the average number of errors made by typist. Okay, that is we do not know. Now, so we decide to estimate the population mean on the basis of the sample size. Okay, that is, we will take two typists instead of whole of the population. We take a sample of two typists. So there are n power. Excuse me, 4 power. Okay, so how many possible combinations with replacement can be done? That is simple random samples with replacement, right? So we know that this will be n power n. So there are four typists were there, and in how many combinations they can be made? 4 power 4. Okay, with replacement. So all possible sample of size n 2 are given below. So now we have calculated this, right? So these are the 16 combinations. That is, say for example, first you select the first typist only, then with replacement, then again the same. Similarly, like this, typist A and typist B, typist A and typist C, because you are selecting two typists now in your sample from the population of four typists. Then typist 1 A and typist B, like this. So typist A has made four mistakes here, 4 and 2, 4 and 3, 4 and 1, like this. So the average of this will be 4, this will be 3, this will be 3.5, this will be 2.5, 3, 2, 2.5, like this. Okay. So when you will be selecting at random the two typists from these four typists, so these will be the sample means you will be observing in your data, right? So from the above table, you can say that the value of sample statistic, sample mean, is varying from sample to sample. That is, sometimes it is coming 4, then 3, then 2.5, sometimes 1.5. Like this, it is varying. Okay. So it's varying from sample to sample. And out of 16 sample, only 4 sample. That is number 4, 7, 10, and 13 have their mean equal to the population mean. Whereas other 12 sample results in some error in the estimation process. The error is the difference between the population mean and the sample mean used for the, right? So now consider all possible values of the sample mean and calculate their probability. Now, using the relative frequency approach, we have already studied in our probability chapter, right? So then we can arrange them every possible value of sample mean with their respective probabilities. So what will be that? So there are 7 sample means, that is 1 error, 1.5 error, 2, 2.5, 3, 3.5, and 4. This has occurred only once, this has 2 times, 3 times, 4 times, 3 times, 2 times, and 1 time. So the associated probability will be total 16, right? So it will be 1 by 16, 2 by 16, 3 by 16, 4 by 16, right? So this will be your, right? So the arrangement of all possible value of sample mean with their corresponding probability is called as sampling distribution of the, right? So you have taken out the sample of two typists, then you have calculated the sample mean for each of them, then the corresponding probability, right? Now, the, therefore, how we can define this? The probability distribution of all possible values of a sample statistics that would be obtained by drawing all possible samples of the same size from the population is called sampling distribution of that statistic. It can be mean, it can be or any other, right? So the sampling distribution of sample mean itself has mean and variance, right? So these values, right? They have their own mean. That is, for one sample we have 1. For 2 samples we got 1.5 mean. For 3 samples 2 mean. For 4 samples we get 2.5. So now mean of the sample means, how will you calculate? That is 1 divided by 60, and for each value you have to multiply it by the frequency. So 1 into 1, then 1.5 has occurred 2 times like this. So it will again come as your population. Or you can calculate it as expectation of the mean, right? So expectation of mean, simply multiply the mean with the probability. Okay, so you will again be getting this 2.5, right? Thus what we have seen for this population, that mean of the sample mean is equal to the population. That is, if you take the samples from the population and consider all possible combinations, so the mean of those mean will be the population, right? Okay, and what you should understand here is that in a population, this was your population, right? So maximum number of occurrence was with the population, right? So more you deviate from the population mean, lesser will be the chances of, right? So that is why when you take out a sample, there are very less chances. When a appreciable population is there and appreciable amount of sample you are taking out, so there are less chances that you will take out the extreme values. So you will be getting in probability sampling the people from every corner, and most of them will be from the middle because they have maximum occurrences in the population, right? So that is why this is equal to your population mean itself, right? So thus we have seen that this for the is equal to the population mean, that is the mean of the sample mean is equal to the population mean is equal to 2.5, right? So the fact that these two means are equal is not a chance, and it can be shown that x bar bar means mean of the sample mean is equal to the population mean for any population and any given sample. Okay, right? So this is very important. So in practice only, a random sample is actually selected and the concept of sampling distribution is used to draw the inference about the population, right? So now there is another thing, that errors in sampling. That is, we have seen that it is not always that every selected sample will be having the same population. It will vary. Okay, so what are those errors? So many mistakes and errors in this research happens because of misleading and bias. A sample which does not represent the population is called a biased sample, right? And according to Yule and Kendall, bias may be due to imperfect instrument or the personal qualities of the observer, defective technique, and other cases. Like experimental error, it is difficult to eliminate entirely, but usually may be reduced. This error can be reduced to relatively small dimension by taking proper care. So there are two types of errors, such as sampling error and non-sampling. So these are discussed below. What are non-sampling errors? So experience survey researchers know that the errors due to other sources are typically greater than errors due to sampling alone. So following are the some of the types of these errors. What are these? Measurement errors, right? So sometimes when you are measuring a quantity, you may commit an error caused by poorly written question, poorly designed questionnaire, or respondent error in completing questionnaire, and so on, right? Then non-response errors may be there, right? Then data coding errors will be there, right? So of these error sources, the first two are typically more severe, that is measurement error and non-response. In mail surveys, non-response error is often the most serious problem. And there are two critical characteristics of non-sampling. First, as mentioned above, their sum is often greater than sampling error. Second, and more insidious, is that these errors are often impossible to estimate for any one survey. especially measurement and monitoring, right? So basically, then what are sampling acts? By definition, when you have collected a sample from a population, you have less than complete information about the population because not all the individuals are included in a sample. This in turn means that there is a chance that sample statistics you calculate, for example, mean of a variable or frequency distribution, may not be an unbiased estimate of the population parameter. That is, it may vary from the population. So the error in the sample estimate is not an intrinsic impediment to analysis, right? So what you can do is for probability sample, sampling theory allows you to calculate the expected amount of error you are going to commit for a particular sample size and sampling method and the specified statistic of interest. So as we have seen earlier in above examples, the value of sample statistic may vary from sample to sample and the sample values are not equal to the population parameter. Now one can be interested to measure it, how to measure it, okay? So as we have already studied that the standard deviation is used as a measure of variation. So how to estimate now these things? So thus for measuring the variation in the values of sample statistics around the population parameter, we calculate standard deviation of the sampling distribution. So say for example, there you have to find out the mean. So what we will do, we will find the standard deviation of that sampling distribution. This is known as the standard error of that statistics, and it can be defined as the standard deviation of a sampling distribution of a statistics is known as standard error, and it is denoted by SE. How you will find that? SE is equal to the square root of 1 by k sigma fi into xi minus mu whole square. This is the formula for the standard, right? So SES will be in previous example we have already done 1 by 16. There were 16 combinations were there, 16 means were there. So 1 into this is the frequency of this, okay, 1 minus 2.5 whole square like this, 2 into 1.5 minus 2.5 whole square like this. So it will be 10 by 16 equal to 0.791. So the computation of this standard error is a tedious process, and there is an alternative. Okay, what is that alternative? So what statistics says, if x1, x2, x3 and up to xn are the random samples of size and taken from a population with mean mu and variance sigma square, then the standard error can be calculated simply by this form. Okay? That is the variance of the population divided by square root of. So the standard error is used to express the accuracy or precision of the estimate, right? That is, it is going to tell you that how much your mean is going to deviate, okay, in a normal distribution. So the standard error is used to express the accuracy or precision of the estimate of population parameter because the reciprocal of the standard error is the measure of reliability or precision of the statistic, right? So standard error also determines the probable limit or confidence limit within which population parameter may be expected to lie with a certain level of confidence, and they are also used for testing hypotheses, right? So standard error discussed above were calculated under the assumption that sampling is done either from an infinite population or from a finite population with replacement. That is, sampling is done with replacement. But in real life sample problem, most sample plans do not permit an element to be selected twice, right? That is, you do sampling without replacement. Consequently, if the population is not large in relation to the size of sample and sampling is done without replacement, right, then we have to multiply the standard error by correction factor. And this standard error, this is your correction, right? Where n is the population size and small n is the samples. So if you multiply this with this correction factor, so your problem of this replacement with without replacement can be balanced. And generally in practice, if the sample size n is less than or equal to 10% of the population size, this correction factor may be ignored for all practical purposes. Only what you have to see is that if your sample size is 10% of the total population size, then you need not to apply this correction, right? Now, one very important, and here we will stop after doing this, is central limit theorem, right? A central limit theorem is most important theorem in statistics, and it was discovered by who? De Moivre again, right? In early 19th century. So according to central limit theorem, if x1, x2, x3 up to xn random sample of size and taken from a population with mean mu and variance sigma square, then the sampling distribution of the sample mean tends to be normal distribution with mean mu and variance sigma square upon n. What is this sigma square upon n? This is nothing but the standard error, right? Because square of the standard error, because in case of samples the variation is given by standard error, right? As sample size tends to large, that is n greater than 30. So whatever the form of parent population, that the parent population be normal or not, take out the samples from the population, so it will follow a normal distribution. Those means of those samples will follow a normal distribution with mean mu and this standard deviation of sigma square upon, and it's variate if we calculate the z score, that is from the mean you minus the population parameter divided by variance, that is standard deviation. So standard deviation will be sigma upon root n in this case. So this will also follows the normal distribution with mean 0 and standard deviation, right? So this also follows the normal distribution with mean 0 and variance unity, and that is the variate z follows the normal standard normal distribution. So this central limit theory tells you, let the parent population be anything. If you take out the same size sample from it, take the mean, so those means will follow the normal distribution, and it will be having the mean of those means will be having the mean mu, and this will be your first, right? And its variate will be again normal with mean 0 and standard deviation. This we have studied already, that is right. So in this lecture we discuss the meaning and various concepts in sampling, particularly of sample and that of population. And there is also detailed discussion on the sample types and sample design process. And there were two types of sampling, such as probability and non-probability sampling were discussed. The type of probability samplings were simple random, systematic random, stratified sample, and cluster sample, while that of non-probability sampling were convenience sample, quota sample, judgment sample, and the snowball. The unit also, this lecture discusses various steps of sampling design process, and this was followed by sampling distribution, error in sampling, central limit theorem to pave the necessary foundation for the forthcoming. So this is all for today, and because there are no queries from the student side, so I am signing off here. Thank you very much for your patience hearing. Thank you.